right, now we're going to dive straight into solving quadratic equations. A quadratic equation is a second degree equation. That means it has a squared term. The zero product property is our best friend here. If m times n equals 0, then m is 0 or n is 0. We'll look at how that works right now. So to apply the zero product property, if I have two factored pieces equal to 0, then either x plus 8 equals 0 or x minus 11 equals 0. I solve each of those. So subtract 8 here, I get x equals negative 8. Or add 11 here, I get x equals 11. That means both of these values, negative 8 and 11, will cause this equation to be true when I plug them in. For this second one, we need to factor first. I have an x squared alone, so I just dive straight into factoring. I have x and x. I need two numbers that multiply to negative 10 and add to positive 9. Well, those are going to be positive 10 and negative 1. So x plus 10, x minus 1. The zero product property says I set each of those factors equal to 0, and then I will solve them. So I subtract 10, I get x equals negative 10. I add 1, I get x equals 1. Both of these numbers, when I plug them in up here, will give me 0. Negative 10 squared is 100, plus 9 times negative 10, which is negative 90. 100 minus 90 is 10. 10 minus 10 is 0. If I plug in 1, 1 squared is 1, plus 9 times 1, so 1 plus 9 is 10. 10 minus 10 is 0. They both work. All right, we have 3x squared minus 48. Well, the first step is GCF. Take out my 3. I'm left with x squared minus 16. And then I factor the x squared minus 16. That's a difference of squares, so it's x plus 4 times x minus 4. Then I set each factor equal to 0. Notice that the 3 should get set equal to 0, but it doesn't give us a solution because 3 doesn't equal 0. Sometimes you'll have an x or something there, though. So x plus 4 equals 0, and x minus 4 equals 0. Subtract my 4, I get x equals negative 4. Add my 4, I get x equals positive 4. Negative 4 and positive 4 will make that equation true. All right, you may have noticed a shortcut that it is the opposite of what's in the factors, right? If my factor is x plus 4, my solution is x equals negative 4. That doesn't quite always work out, though, because if I factor this one, the only way to break apart 2x is 2x and x. 21, I can use 21 and 1, or 3 and 7. That's it. I think it'll be 3 and 7. I think it'll go 3 and 7 to make a 7x, and this will be a 6x. I want positive 7x minus 6x, so a plus on my 7, minus on my 3. Now we set each factor equal to 0. If I set 2x plus 7 equal to 0, and x minus 3 equal to 0. For 2x plus 7, I have to do two steps now. I subtract the 7, giving me 2x equals negative 7, and then divide by 2, giving me x equals negative 7 over 2, or negative 3.5. The other one is easier. I just add the 3, and I get x equals 3. So be careful when your factor has a coefficient in it. Your answer won't quite just be the opposite. All right, for this next one, we're going to start by factoring. The only way to break apart x squared is x and x. 33, I can use 33 and 1, or 11 and 3. I'm guessing it's positive 11, negative 3. Our shortcut here, if they're just these factors, x equals, the opposite of plus 11 is negative 11. And the opposite of minus 3 is positive 3. There are our solutions. This next one adds an extra twist. It is not equal to 0. If I get it equal to 0 and just add the 12 over, the 12 can't combine with anything yet, because that 7 is in parentheses, so it can't combine. Oops, sorry, I added and I got 0. There we go. So we need to distribute. 2x times 2x makes 4x squared. 2x times negative 7 is minus 14x, plus 12 equals 0. Now I take out my GCF, which is 2, leave me 2x squared minus 7x plus 6. And now I factor. To break apart 2x squared, I get 2x and x. To break apart 6, I can use 6 and 1 or 2 and 3. I believe it is 2 and 3 because both are minuses. That gives me negative 3x and negative 4x, which makes my negative 7x. Now I set each factor equal to 0. Each factor are those pieces in parentheses. Well, 2 doesn't equal 0. That one doesn't do anything for me. I add 3, giving me 2x equals 3. Divide by 2, x equals 3 halves. Or simply add 2 over here, and x equals 2 is our other solution. In a quadratic, you should always get 2 solutions, unless they're the same. Then we have the square root property. If x squared equals k, then x is equal to positive or negative square root of k. To undo a square, you use a square root. One thing to be careful of here. If x squared equals 4, then our solution is x equals positive or negative square root of 4, which is 2. If I tell you x equals the square root of 4, then x just equals 2. So if you're undoing a square, you get 2 answers. If it already has the square root in it, you only get 1 answer. So just be very careful about that tiny little difference. So let's use the square root property. If a squared equals 49, to undo a square, I square root. I get a equals positive or negative 7. For w plus 3 equals 8. Sorry, w plus 3 squared equals 8. Well, our squared term is all alone, so we undo the square, making it w plus 3 equals positive or negative square root of 8. Now, the square root of 8 can be simplified. There's a couple different ways to do this. I personally like to say what perfect square multiplies into 8. Our perfect squares are 1, 4, 9, 16, 25, on and on. 4 times 2 is how 8 breaks down. You can split those 2 square roots apart. The square root of 4 is 2. The square root of 2 is stuck. The square root of 8 simplifies to 2 square root of 2. So we have positive or negative 2 square root of 2. And then we just subtract the 3. Now, since this part has a square root on it, and the 3 does not, we can't actually combine them. We treat them like separate terms. Treat them like variables that aren't like terms. Negative 3 plus or minus 2 square root of 2. Now, if I wanted to put that on a graph, I'd probably type it in my calculator. Negative 3 plus 2 square root of 2, get a number. Negative 3 minus 2 square root of 2, get a decimal number. But for our purposes, we want the exact solutions. And now completing the square. To complete the square, we will isolate the variable terms on one side of the equation. We'll factor a to make the leading coefficient 1. And then we'll complete the square. To complete the square, you'll add b divided by 2 squared to both sides. You might have to multiply by a. Then you'll factor the resulting perfect square trinomial, apply the square root property, and solve for x. I'll show you exactly what that means, but when I talk about a and b, remember we're talking ax squared plus bx plus c equals 0. So we get that c out of there first, then get a out of there, then b divided by 2 squared. So here we go. All right, to complete the square, we first get the variable terms alone. So I'm going to add that 23 to both sides. I have x squared minus 4x equals 21. Notice I leave myself a little space when I'm completing the square. Now we want a to be 1, so our leading coefficient should be 1. It already is. Perfect. Now is the complete the square step. We are going to add some number on both sides of the equation. If I add the same thing on both sides, it's still balanced, so it doesn't matter what I add. I could add 3,000, I could add negative 62, I could add pi, whatever I want. To make my life easier, I take my b value, negative 4, I divide it by 2, and then I square it. Negative 4 divided by 2 is negative 2, and negative 2 squared is 4, so I am adding 4 to both sides of my equation. Now we factor. The reason we chose 4 here is because this will factor into x something squared. That something match right here before we squared b over 2 minus 2. And then 21 plus 4 is 25. Now we undo the square by square rooting. leaving with x minus 2 equals positive or negative 5. And then we add the 2. But if you can actually figure these out, you cannot leave it as 2 plus or minus 5. 2 plus 5 makes 7. 2 minus 5 is negative 3. Those are my two solutions, found by completing the square. So let's try another one. We start by getting the x's alone. Add 6 over. I have 8x squared plus 16x equals 10. Well, this time our a value is not 1, so we want to make it 1. We're going to divide everything by a, which is 8 in this case. So I have x squared plus 2x equals 10 over 8, which simplifies to 5 over 4. Now we do our completing the square process. We add some number to both sides. That number is going to be our b value over 2 squared. Well, 2 over 2 is 1, and 1 squared is 1. We are adding 1 to both sides of the equation. Now this side will factor nicely into x plus 1 squared, because remember, it'll match that. It's a positive 1, so it's a plus. And 5 over 4 plus 1, remember we want to make that a 4 over 4 to make this 9 over 4. Then we undo our square by taking the square root of both sides. When you take the square root of a fraction, we take the square root of the numerator, which would be 3, over the square root of the denominator, which is 2. And then I subtract 1, making it negative 1 plus 3 over 2, and negative 1 minus 3 over 2. Now these are actual numbers, no square roots left in them, so we have to figure this out. Negative 1, remember, we can rewrite as negative 2 over 2. And negative 2 over 2 plus 3 over 2 is 1/2. And same thing for this one, 2 over 2 minus 3 over 2. That makes negative 5 over 2. Those are our two solutions. All right, let's complete the square again. First step, get that equal to just the x values. Oh, you can't see it, sorry. There we go. Get my x's alone, I'll add 6. I have 3x squared minus 24x equals 6. Now we need to get our a value out of there, so divide everything by that 3. That leaves me x squared minus 8x equals 2. Now we pick our number to add to both sides. To find that number, we take b divided by 2 squared. b is now negative 8. Divide that by 2 and square it. I get negative 4 squared. We're going to add 16 to both sides. Now I factor x squared minus 8x plus 16 factors into x minus 4 squared. Remember, it'll always match right there. And that'll equal 18. Now I square root both sides. I get x minus 4 equals positive or negative square root of 18. But we want to simplify the square root of 18 also. What perfect square goes into 18? Well, 9 times 2. We break those apart. The square root of 9 times the square root of 2. The square root of 9 is 3. The square root of 2 is stuck. So we rewrite that as x minus 4 equals positive or negative 3 square root 2. And then we add the 4. Remember that 4 cannot combine with a square root term, so it's just 4 plus or minus 3 square root 2. Standard procedure is to put that number first and then the plus or minus and then the part with the square root. And finally, everybody's favorite, the quadratic formula for ax squared plus bx plus c equals 0, where a is not 0. This quadratic formula will always work. Please note that it has to be equal to 0. If it's not equal to 0, get it equal to 0, and then plug in negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's use the quadratic formula. Well, it's got to be equal to 0, and I have to not have parentheses, so I need to distribute. X times x is x squared. X times negative 8 is negative 8x equals 3. Still not equal to 0. Subtract that 3 over. We get x squared minus 8x minus 3 equals 0. Now I can go into the quadratic formula. Our a value is 1, because there's nothing in front of x squared. Our b value is negative 8, because it's the coefficient on the x. and our c value is negative 3 because it's our constant. So quadratic formula, negative b, so negative negative 8, plus or minus the square root of b squared, so negative 8 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is still 1. And we simplify. Double negative makes it a positive 8, plus or minus the square root. Negative 8 squared is positive 64. Minus 4 times 1 times negative 3 makes it a plus 12. And 2 times 1 makes it 2. So now we have 8 plus or minus the square root of 76 all over 2. Now comes the question, can I break down the square root of 76? Is there a perfect square that goes into it? I think maybe 4 does. 4 times 19. Awesome. Square root of 4 times square root of 19 makes it 2 square root 19. I happen to know 19 is prime, so it can't go any further. We have 8 plus or minus 2 square root 19 all over 2. Now we can do some division. Since 8, 2, and 2 can all be divided by 2, divide all of them by 2. So our values of x are 4 plus or minus 1 square root 19 over 1. We don't need the over 1. There we go. Notice that the 19 was stuck in a square root. It was not divided by that number. All right, let's use quadratic formula again. Our a value in this case is 9. Our b value is negative 12. Our c value is negative 1. So the quadratic formula is negative b, which is negative 12, plus or minus the square root of b, which is negative 12, squared, minus 4 times a, which is 9, times c, which is negative 1, all over 2 times a, which is 9. And now we simplify. Double negative makes positive 12, plus or minus the square root of positive 144 plus 36, all over 18. 144 plus 36 is 180 over 18. Now we break down 180. Well, I know 9 definitely goes into it, but I think something bigger might. Let's find out. 9 times 20, right? Square root of 9 times square root of 20. Square root of 9 is 3. Square root of 20. But 20 can actually be broken down again into 4 times 5. So really I have square root of 4, square root of 5 with that 3. Square root of 4 is 2. 3 times 2 makes 6. Square root of 5. All right, 12 plus or minus 6 square root of 5 all over 18. And now all 3 of my coefficients can be divided by 6. So let's do that. I get 2 plus or minus the square root of 5 over 3. And there are my 2 solutions. If I wanted those as a decimal, I would type in 2 plus the square root of 5, divide that by 3, and then 2 minus the square root of 5, divide that by 3. And now some more complicated quadratics, just when you were getting used to it, right? So we're going to make an appropriate substitution to solve. If you look here, I have something squared plus 36 times something plus 35. If I say y equals 2x squared minus 3, I can substitute and call this y squared plus 36y plus 35 equals 0. Then I can factor it. I can say y plus 35, y plus 1. And I solve those, I get y equals negative 35 and y equals negative 1. But since I substituted, I got to substitute back around. So 2x squared minus 3 equals negative 35, or 2x squared minus 3 equals negative 1. When I add 3 here, I get 2x squared equals negative 32. Divide by 2, I get x squared equals negative 16. If I try to square root that, I cannot square root a negative, so this has no real solution there. Over here, if I add 3, I get 2x squared equals 2. Divide by 2, I get x squared equals 1. Square root that, and I get x equals positive or negative 1. So So my only answers are positive or negative 1. And for another one of these substitution ones, I noticed that x squared minus 6 is in both. So we'll say y equals x squared minus 6, and we'll substitute that in. Y squared plus 33y plus 62 equals 0. Now I factor this, and it factors into y plus 31 times y plus 2. So y equals negative 31, and y equals negative 2. But we're not quite done yet. We need to substitute this back in. So x squared minus 6 equals negative 31, and x squared minus 6 equals negative 2. Add the 6. I get x squared equals negative 25. When I try to square root that, I get no real solution. Cannot square root a negative number in the real number line. And when I add 6 here, I get x squared equals 4. Square root that, I get x equals positive or negative 2. Those are my only two actual solutions. And then you'll do some practice problems and have some practice on your own.